Welcome to Openstax, Contemporary Mathematics, Chapter 3, Section 2, The Integers. Figure 3.11, a ledger comparing assets to debts, resulting in net wealth. Credit goes to that, and it's just a picture of a bunch of different things on a computer screen. After completing this section, you should be able to 1. Define and identify numbers that are integers. 2. Graph integers on a number line. 3. Compare integers. 4. Compute the absolute value of an integer. 5. Add and subtract integers. 6. Multiply and divide integers. Positive net wealth is when the total value of a person's assets, such as their home, their 401k, their car, and savings account balance, exceed that of their debts, such as car loans, mortgages, or credit card debt. However, when the total value of debt exceeds the total value of assets, then the person has negative net wealth. Expressing the negative net wealth as a negative number allows people to work with the positive net values and negative net values with the same mathematical processes and in the same applications. This section introduces the integers and operations with integers, defining and identifying integers, extending the counting numbers to include negative numbers and 0 forms the integers. Any other number that cannot be written as the set negative infinity all the way to negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way to infinity, close, is not an integer. Example 326. Identifying integers. Which of the following are integers and which is not? Negative 3 is an integer, as it is the negative of a counting number. The square root of 24. This is not written as an integer. Entering the square root of 24 into a calculator such as Desmos, the result is 4.899 rounded off. Since this is not an integer, then square root of 24 is not an integer. 36 divided by 4. Since 36 divided by 4 is 9, and 9 is an integer, then 36 divided by 4 is an integer. 45 is an integer, as it is a counting number. 63.9 is not an integer, because it is not a counting number and not the negative of a counting number. 2/7. Dividing 2 by 7 results in a number less than 1, but greater than 0, so it is between two consecutive integers, so 2/7 is not an integer. Negative 16.0 is an integer since the decimal part is 0. Your turn 326. Which of the following are integers? 1. Negative 214. 2. 38/11. 3. Square root of 90. 4. Square root of 121. 5. 420/35. Graphing integers on a number line. Integers are often imagined as steps along a path. You start at 0 and going to the left is going backward, or in the negative direction, while going to the right is going forward, or in the positive direction. A number line helps envision the integers. This also means that an integer gives magnitude, size, and direction. Positive is to the right, negative is to the left. Graphing an integer on the number line means placing a solid dot at the integer on the number line. So figure 312, we have arrow, and then little hash marks, equal distance from each other, starting at negative 7, then negative 6, negative 5, all the way to 7, and then another arrow. And that's the number line. Video, graphing integers on the number line. Example 327, graphing numbers on the number line. Graph the following on the number line. 1, 1, 2, negative 4, 3, 3. Solution. So figure 313, we have our number line, same one as figure 312. However, there's a closed-in dot at the number 1, and it says x equals 1. 2. Same figure, but this is 314. Now the dot is on negative 4, and x is negative 4. And then 3, the dot's on 3, figure 315. Your turn 327. Graph the following numbers on the number line. 1, negative 10, 2, 4, 3, 0. Comparing integers. When determining if one quantity or size is larger than another, we know it means there is more of whatever is being discussed. In terms of positive integers, we can envision that larger integers are farther to the right on the number line. This idea applies to negative integers also. This means that a is greater than b. When a is to the right of b on the number line, we write a greater than b. When a is greater than b, we can also say that b is less than a. On the number line, b would be to the left of a. We write b is less than a. We need to recognize that a greater than b means the same thing as b less than a. This can be seen on the number line in figure 316. On this number line, a is to the right of b, so a is greater than b. But this means b is to the left of a, so b is less than a. So here we have the number line, 316. We have the arrows, and then 2 dots. B is left, a is right. Video, comparing integers using the number line. Example 328, comparing integers using a number line. Determine which of -6 and 4 is larger using a number line, and express that using both the greater than and the less than notations. Solution. To illustrate this, we use the number line 317, and it's the same number line from 312, and then the closed dots are on -6 and 4, but the one on 4 is in a different color. Since -6 is to the left of 4, then -6 is less than 4. We can write this as -6 less than 4. Another way of expressing that is 4 is greater than -6. So we can also write 4 greater than -6. Your turn, 328. Determine which of -38 and 27 is larger using a number line, and express that using both greater than and the less than notations. Example 329. Comparing negative integers. Determine which of -6 and -2 is larger, and express that using both the greater than and the less than notations. Solution. To illustrate this, we use a number line. So figure 318, same as figure 312, but it's the 6 and the -6 and the -2 filled in. Since -6 is to the left of -2, then -6 is less than -2. We can write this as -6 less than -2. Another way of expressing this is that -2 is greater than -6. So we can also write -2 greater than -6. Caution. People often ignore the negative signs and think that since 6 is greater than 2, -6 is greater than -2. To avoid that error, remember that the greater number is to the right on the number line. Your turn, 329. Determine which of -63 and -213 is larger, and express that using both the greater than and the less than notations. Example 330. Comparing integers by quantity. Determine which of 27 and 410 is larger, and express that using both the greater than and the less than notations. Solution. When thinking about quantity, 410 is more than 27, so 410 is greater than 27, and 27 is less than 410. We can write this as 410 greater than 27, or as 27 less than 410. All right, your turn, 330. Determine which of 101 and 98 is larger, and express that using both the greater than and the less than notations. The absolute value of an integer. When talking about graphing integers on the number line, one interpretation suggests it is like walking along a path. Negative is going to the left of 0, and positive is going to the right. If you take 30 steps to the right, you are 30 steps away from 0. On the other hand, when you take 30 steps to the left, you are still 30 steps away from 0. So in a way, even though one is negative and the other positive, these two numbers, 30 and -30, are equal since both are 30 steps away from 0. The absolute value of an integer, n, is the distance from n to 0, regardless of the direction. The notation for absolute value of the integer is vertical and vertical. If we think of an integer as both direction and magnitude, or size, absolute value is the magnitude part. Calculating the absolute value of an integer is very straightforward. If the integer is positive, then the absolute value of the integer is just the integer itself. If the integer is negative, then to compute the absolute value of the integer, simply remove the negative sign. Keeping in mind the number line as a path, when you've gone 10 steps to the left of 0, you have still taken 10 steps, and the direction does not matter. Video. Evaluating the absolute value of an integer. Example 331. Calculating the absolute value of a positive integer. Calculate the absolute value of 19. Solution. Since the number inside the absolute value symbol is positive, the absolute value is just the number itself. So the absolute value of 19 is 19. Your turn, 331. Calculate the absolute value of 38. Example 332. Calculating the absolute value of a negative integer. Calculate the absolute value of negative 435. Solution. Since the number inside the absolute value is negative, the absolute value removes the negative sign. So absolute value of negative 435 is 435. Your turn 332. Calculate the absolute value of negative 81. Adding and subtracting integers. You may recall having approached adding and subtracting integers using the number line from earlier in your academic life. Adding a positive integer results in moving to the right on the number line. Adding a negative integer results in moving to the left. Subtracting a positive integer results in a move to the left on the number line. But subtracting a negative integer results in a move to the right. This leads to a few adding and subtracting rules, such as Rule 1. Subtracting a negative is the same as adding a positive. Rule 2. Adding two negative integers always results in a negative integer. Rule 3. Adding two positive integers always results in a positive integer. Rule 4. The sign when adding integers with opposite signs is the same as the integer with the larger absolute value. These rules are good to keep in the back of your mind, as they can serve as a quick error check when you use a calculator. Example 333. Adding integers. Use your calculator to calculate 4 plus negative 7. Explain how the answer agrees with what was expected. Solution. Using a calculator, we find that 4 plus negative 7 is negative 3. Since we are adding integers with opposite signs, the sign of the answer matches the sign of the integer with the larger absolute value, which is absolute value of negative 7 is 7. Your turn 333. Use your calculator to calculate negative 18 plus 11. Explain how the answer agrees with what was expected. Example 334. Subtracting positive integers. Use your calculator to calculate 18 minus 9. Explain how the answer agrees with what was expected. Solution. Using a calculator, we find that 18 minus 9 equals 9. Since 18 was larger than 9, we expected the difference to be positive. Your turn 334. Use your calculator to calculate 38 minus 100. Explain how the answer agrees with what was expected. Example 335. Subtracting with negative integers. Use your calculator to calculate 27 minus negative 13. Explain how the answer agrees with what was expected. Solution. Using a calculator, we find that 27 minus negative 13 is 40. Since we're subtracting a negative number, it is the same as adding a positive. So this is the same as 27 plus 13 equals 40. Your turn 335. Use your calculator to calculate 45 minus negative 26. Explain how the answer agrees with what was expected. Example 336. Adding integers with opposite signs. Use your calculator to calculate negative 13 plus 90. Explain how the answer agrees with what was expected. Solution. Using a calculator, we find that negative 13 plus 90 equals 77. Since we are adding integers with opposite signs, the sign of the answer matches the sign of the integer with the larger absolute value, which is positive since 90 is positive. Your turn 336. 1. Use your calculator to calculate 19 plus negative 36. Explain how the answer agrees with what was expected. One use of negative numbers is determining net worth, which is all the wealth someone owns less all that someone owes. Sometimes net worth is positive, which is good, and sometimes net worth is negative, which can be stressful. Example 337. Calculating net worth. Jennifer is owed $50 from her friend Janice, but owes her friend Pat $87. What is Jennifer's net worth? Solution. Net worth is the amount that one is owed minus the amount one owes. Jennifer is owed $50 but owes $87. So her net worth is $50 minus $87 equals negative $37. The negative indicates that Jennifer owes more than she is owed. Your turn 337. Christian is owed $180 from his friend Chanel, but owes his friend Jeff $91. What is Christian's net worth? Multiplying and dividing integers. Similar to addition and subtraction, the signs of the integers impact the results when multiplying and dividing integers. The rules are fairly straightforward, but again rely on the direction on the number line. There are only two rules. Rule 1. When multiplying or dividing two integers with the same sign, the result is positive. Rule 2. When multiplying or dividing two integers with opposite signs, the result is negative. Just as before, these rules can serve as a quick error check when using a calculator. Example 338. Multiplying positive integers. Use your calculator to calculate 4 times 8. Explain how the answer agrees with what was expected. Solution. Entering 4 times 8 into your calculator, the result is 32. This agrees with our expectation. The numbers have the same signs, so the result is positive. Your turn 338. Use your calculator to calculate 81 times 26. Explain how the answer agrees with what was expected. Example 339. Multiplying integers with different signs. Use your calculator to calculate 9 times negative 10. Explain how the answer agrees with what was expected. Solution. Entering 9 times negative 10 into your calculator, the result is negative 90. This agrees with our expectation. The numbers have opposite signs, so the result is negative. Your turn 339. Use your calculator to calculate negative 18 times 13. Explain how the answer agrees with what was expected. Example 340. Dividing integers with different signs. Use your calculator to calculate 400 divided by negative 25. Explain how the answer agrees with what was expected. Solution. Entering 400 divided by negative 25 into your calculator, the result is negative 16. This agrees with our expectation. The numbers have opposite signs, so the result is negative. Your turn 340. Use your calculator to calculate negative 116 divided by 4. Explain how the answer agrees with what was expected. Example 341. Dividing negative integers. Use your calculator to calculate negative 750 divided by negative 3. Explain how the answer agrees with what was expected. Solution. Entering negative 750 divided by 3 into your calculator, the result is 250. This agrees with our expectation. The numbers have the same signs, so the result is positive. Your turn 341. Use your calculator to calculate negative 77 divided by negative 11. Explain how the answer agrees with what was expected. At the end of a season, a team may wish to buy their coach an end-of-season gift. It makes sense to share the cost equally among the members. To do so, the team would need to find the average or mean cost per member. The average or mean of a set of numbers is the sum of the numbers divided by the number of values that are being averaged. Example 342. Finding the average of a set of numbers. The daily low temperatures in Barrie, Ontario for the week of February 14th, 2021 were negative 20 degrees, negative 12 degrees, negative 15 degrees, negative 23 degrees, negative 17 degrees, negative 13 degrees, and negative 19 degrees Celsius. What was the average daily temperature for the week of February 14th, 2021 in Barrie? Solution. Step 1. To find the average daily temperature, we first need to add the temperatures. Negative 20 plus negative 12 plus negative 15 plus negative 23 plus negative 17 plus negative 13 plus negative 19 equals negative 119. Step 2. That sum will then be divided by 7 since we are averaging over 7 days, giving negative 119 over 7 equals negative 17. So the average daily temperature in Barrie, Ontario, the week of February 14th, 2021 was negative 17 degrees Celsius. Your turn 342. Banks and credit cards often base their interest on the average daily balance of an account, which is the average of the balance from each day of the period. The account balance of Jada's checking account on each day of the week of December 13th, 2020 was $12.50, $6.73, negative $1,500, $1,000, $7.85, $7.85, and $7.10. What was Jada's average daily balance for the week of December 13th, 2020? Assume Jada pays no fees for a negative balance.